EDX Mechanics 1, Work Energy and Power 2, Power. A definition of power. So there are two ways of digging this hole. There's the hard way with a spade or the easy way with a JCB. Assuming we use both methods to dig a similar hole with the earth placed in a similar position, the actual work done would be more or less the same. However, the JCB will do it much quicker as it has more available power. So power is the rate at which work is done. Power is a scalar quantity and its SI unit is a watt. So since power is a scalar quantity, it will always have a positive value. 1 watt is defined as the power produced when 1 joule of work is done in 1 second. The watt is a very small unit of power, and the more familiar kilowatt is more commonly used. So if power is the rate at which work is done, then power equals work done by the driving force or the engine divided by the time taken. Caution needs to be taken when using this, as it assumes that the working is being done at a constant rate. Otherwise, it can only be used as a particular instant, or we talk about average power. So you may get questions that ask you to calculate the average power, since may not be clear whether the work is done at a constant rate. So in this example, find the average power of a lift that carries a load of 2,000 kilograms when full upwards through 30 meters in 20 seconds. So the lift is doing work, and the work is needed in order to raise the object. So the work done by the lift is used to increase the potential energy. It's very important in questions like this to make a distinction between the work done by and the work done against a force. So we're interested in the work done by the lift. So the work done by the lift has increased the potential energy, so the work done by the lift will be mgh, so that's 2,000 kilograms, gravity is 9.8, and it has been raised 30 meters. So the work done by the lift in raising the lift is 588,000 joules, or if you prefer, 588 kilojoules. So we don't know whether that work has been done at a constant rate, so we can only really talk about the average power of the lift mechanism. So average power is work done by the lift divided by time taken. So the average power is 588,000 joules of work has been done by the lift, and it was done in 20 seconds. So the average power of the lift is 29,400 watts, or if you prefer, 29.4 kilowatts is the average power. And you can see the method laid out there. So in this next problem, the diagram shows a crate of mass 180 kilograms. It's been pulled up by a winch up a rough slope. Its speed is constant at 1.2 meters per second, and the frictional force opposing the motion is a constant 450 newtons. It takes 30 seconds to winch the crate to the top. What is the average power of the winch? It's worth noting here that the speed is constant, so we do not need to be considering kinetic energy, because there will be no change in kinetic energy. We can focus on the work done by or against the forces. So this time we need to find the work done by the winch. And the winch has done two things. It's raised the object up, so it has increased the potential energy, and it has also had to overcome the frictional force. So the work done by the winch, it will be the work done against gravity and the work done against friction. So let's have a look at those separately. And before we do those, we need to find out how far the crate has travelled. So the distance travelled is going to be the speed, which is 1.2 meters per second, and it travelled for 30 seconds. So the distance along the slope is going to be 36 meters. So let's have a careful look at how much work the winch has done against gravity. So how much work did it have to do to overcome gravity? Well, that's going to be the gain in potential energies, that's mgh. So that's 180 times 9.8 times the height, and the height will be 36 sine 30, having done a little bit of trigonometry. So the work done against the weight is going to be 31,752 joules. We also want the work done against the resistive force. So how much work did the winch have to do against the friction? And the work done by the friction, or against the friction, was 450, and that 450 newtons moved a distance of 36 meters. So the work done against friction is 16,200 joules. Now we can talk about the work done by the winch. The work done by the winch, well, the winch had to overcome gravity and it had to overcome friction. So the total work done by the winch is 31752 plus 16,200. So the winch had to do 47952 joules of work. So now we can think about the average power. So the average power of the winch is the work done by the winch, which was 47952, divided by the time taken to pull the crate up the hill, which was 30 seconds. So the average power is 1,600 watts to 3 significant figures. So there we can see the vertical height being calculated as 18 meters, and we can see the work done against friction and the work done against gravity in order to calculate the work done by the winch. In the next session we're going to be looking at power, force and velocity.